Now that we've seen how to use visual models to aid with calculation of multiplication, I want to explore some more ways of using this to do more complicated calculations. So let's start with, for example, 48 times 7. And now I'm going to draw the grid picture of 48 times 7, and I'm going to do the 48 across and 7 down. So I like to count by fives. So I'm going to count starting from this upper left corner, 5, 10, 15, 20, 5, 30, 35, 40, 45, 46, 47, 48. Okay, so there's 48. And you notice that I'm kind of ticking off by fives, and I can actually see those groupings of fives kind of by looking at a group of 5 always has a middle box, right? You can see that middle box in there. So there's a middle box and 2 on the other side. That helps me to, to visually see a group of 5 without necessarily having to count each piece. Okay, so there's 48 across, and there's going to be 5, 6, 7 down. So now I'm going to use my rectangle. This shows me how big my block should be. So whatever number of little squares are in this big rectangle, that is 48 times 7. So this is 48 across and 7 down. So there's a lot of different ways that you might consider multiplying 48 times 7. And one of the things is multiplying by tens is easier. So if I was to block off one of these groups of 10, this is 10 times 7, and so that's 70 in here. So that I can actually see then there's another 70, there's another 70, there's another 70, there's 10, 10, 10, and then 8 times 7. Let's see, how do we do that? Let's see, I've got 8 times 5 is 40, and 8 times 2 is 16. Okay, so this tells me I've got 4 groups of 70, and then plus 40 and 16. This is 280, because I remember 4 times 7 is 28, and plus 56 is, oh, let's do this. 280 plus 50 is 330. So it's 336. Okay, so that's 48 times 7 is 336. Now I want to see about another way of doing this. So let's do this again. And maybe instead of breaking up the 48 in terms of groups of 10, maybe I actually think, well, 48 is very close to 50, and I feel like I could do 50 times 7 pretty easily. So I'm going to do this. I'm going to count out to 50 again. Okay, so now we have, this is 7 times 50. And that one feels a little bit easier to me because I know 7 times 5 is 35. So 7 times 5 times 10 would be 350. So that is 350. But 7 times 48, we should take out 2 of those rows of 7. So let's remove those. And that is 14 here. 2 times 7 is 14. So what we have is 50 times 7. 50 groups of 7 minus 2 groups of 7 is 350 minus 14. So subtracting 10 would get down to 340. So it would be 336. You know, there was another way that I thought of that I didn't even realize that I didn't think of with the numbers, but drawing the picture kind of inspired me to think of this, which is kind of noticing these groups of 5. So this group of 5 here and this group of 5. And so this is a 5 by 5 rectangle, or 5 by 5 square that has 25 in it. So let's actually, I'm going to do this one more time. So starting here, and I'm going to group by 5s. And so this time I'm going to see, you know, they've got these groups of 5 that I'm going to divide up. And at this point, I'm going to do one more division here. So here, I'm noticing these nice 25s. So here's 5 and 2. So each of these is 25, right? Okay, so these are 5s, and then this one, so this is 5, 10, 15, 20, 30, 25, 30, 35, 40, 45, and 3 more makes 28. So now I see this one is 3 by 5, so that's 15. And each of these is 2 by 5, so those are 10s. I love adding up 10s. And this one is a 2 by 3, so it's 6. So now I see, well, 25s, I like 25s because I think of quarters, and that makes me think like, you know, 4 quarters is $1. So every time I see 4 of these groups of 25, that is 100. So there's 100 there and 100 here. This picture is actually helping me see this in a way that I think, for me personally, I wouldn't have seen that with just the numbers. So what we've got is, let's count up what we've got. So there's 200s. And then there's 25 and 15. And then there's, how many of these? These are, there's 9 of them, right? So 9 tens is 90. And finally, we have plus 6. So let's see, there's 200 and 25 and 15 is 40 and 96. So 240 plus 96. I know that 240 plus 100 would be 340. So let's back off of that by 4. 340 minus 4 is 336. Okay, so that's another way, yet another way to multiply 48 times 7. So I just want to emphasize here that these visual models help us to have some flexibility for how we do our calculations. And the way that we do the calculations can be very personal. Each person might do a very different calculation than their neighbor. But let's take a look at some sort of more standard ways of doing this. And I want to look at, I want to do two-digit numbers. So let's multiply, for example, 39 times 24. So I'm going to draw out the grid. So here we have 39 times 24. And I want you to think about what parts of this, if I break up this huge rectangle, what parts of this are easy to calculate? And the thing is, you might actually come up with a couple different answers. But one of the things that I hope you see is that these groups of 10 are, multiplying by 10s is easier than other things. So if I multiply this 10 by 10 here, this 10 by 10 block is 100, right? So one nice thing is to just think about separating out these groups of 10. So when I separate out those groups of 10, every one of these 10 by 10 squares is 100 squares, right? So 10 squares by 10 squares, there's 100 squares in this. So I have 100 here, 100 here, 100 here, 100 here, 100 here. Okay, wonderful. So these are the, if you're looking at kind of base 10 representations, one of these squares represents 100. And then for this one, this is 9 by 10, another 9 by 10. These are 10s, and this one is 4. So I'm going to do something that, I think is useful to do a couple times, but not necessarily every single time. I am going to actually draw out these lines of 1. Okay, now when I do that, now I see these bars. Each one of these is a group of 10, and 9 tens, this is 9 groups of 10, is 90. So this here is 90. And we have here another 90. Now this one here is 4 groups of 10, so it is 40. Another 40. And this is 9 groups of 4, 4 groups of 9, so that's 36. Okay, and we can see 36 individual blocks here. And so now when we look at this, we have 6 groups of 100, 2 groups of 90, and 3 groups of 40, and one group of 36. Okay, so let me write that down. So this is 6 groups of 100, and 2 groups of 90, and 3 groups of 40, and 36. So this is 600 plus 180 plus 120 plus 36. Let's see, I like the 80 plus 20 is 100 plus another 100 plus another 100, so this is 300. So this is 900 plus 36, 936. So this means if I was to count every single one of these little boxes in here, one of these little squares, I would have 936 individual squares. But of course, instead of counting them one by one, this sectioning off this grid allows us to count them in groups. Okay, I want to do this again. I'm going to do it a couple more times, probably 2 or 3 more times, because I'm going to kind of remove some of the details at each round. So let me do this again, removing some of the details. 39 times 24. Okay, so I sectioned this off, and one of the things that I'm going to do is I'm going to still break it up, but instead of breaking it up by the full tens, like, let me show you how it is broken up by tens first. So there's my tens, but I really kind of only want to concentrate on the, the groupings of tens. So here are 3 tens, and I'm going to section those 3 tens off, and I'm going to section these 2 tens off in the 20. So what I have here is 20 plus 4 and 30 plus 9, okay? And when I do that, I can see this 20 times 30 is the same as 6 groups of 10 times 10, but I can kind of address that as one whole group, as this is 600, okay? And the 20 times 9, I can see that as 2 groups of 10 times 9, but as a whole, 20 times 9 is 180. And then here, 4 times 30 in this group is 120, and then 4 times 9 is 36. So just breaking up, what I'm really doing is I'm breaking this up specifically by place value. And this gives me that 39 times 24 is going to be 600 plus 180 plus 120 plus 36, which adds up to 936. Okay, so the first way we did this is we really broke up each of the tens, and then when we got done with tens, we broke up each of the ones. That really allows us to see clearly these blocks of 100. 10 times 10 is 100, and then we see these strips of 10 here, so this is 90, and then we see the individual squares. Now, with slightly less detail, we can now see this as just 20 times 30 is 600, and I kind of want to ignore the blue lines here. Okay, so ignoring those individual divisions, I see 600 is 20 times 30, 20 times 9, 180, 4 times 30, 120, and 4 times 9 is 36. Like, this is really same picture, but slightly less detail. This one, I think, gives a little bit more clarity to what exactly is going on. But once you get accustomed to that, once you start to feel comfortable with it, this shows the same picture, but with less detail. Now what I want to do is actually look at what is the standard procedure that is taught for how to multiply numbers, and see how this relates to what we're doing here. It is actually related, I promise. So let's do this one more time. We have, what is it, 39 times 24? 39 times 24. So when we're taught to do 39 times 24, a lot of times the stacked method, you write one above the other, and you're taught to multiply the 4 times 9 is 36, and you write down the ones digit, 36, and then you keep the 3 in your head, and with that 3, you carry it. You carry it, but you do a very specific thing to the 3. It's not like adding, like when you carry it for addition. What you do first is you multiply the 3 times 4 is 12, multiply that 3 times 4, and then add that carry. So 12 plus 3 is 15, and you write that here. And that's a lot of things that are supposed to happen inside your head. And then what you do is you move over. Sometimes you're taught to write a 0 here. Sometimes you're just taught to leave a blank there. You move over one digit, and then you multiply 2 times 9 is 18. I write down the 8 here, and then I carry the 1, which is different from the 3 that I carried before. And 2 times 9 is 18, and then I do 2 times 3 is 6, and then add this 1 is 7. Okay, and then I add these two numbers up. 6, 13, 9. Okay? Now, let's look at this again from a different perspective. 39 and 24. This is that 3. If you think about what that 3 means, that 3 doesn't mean 3. That means 3 tens. So this is 30 and 9, and this is 20 and 4. Okay, that 2 is not a 2, it's a 20. So if I was to look at this piece by piece, breaking those up by place value, if I do 4 times 9, that's 36. Okay, and I'm just going to write down that 36. 4 times 9 is 36. Now, I do 4 times 3, but this is not 4 times 3. This is 4 times 30. That's 4 times 30. Okay, 4 times 30 is 120. And I can think about this by kind of covering up that 0. 4 times 3 is 12. But I also have a times 10 in there, since that 3 is 3 times 10. So that's where that extra 0 comes from. Now I have multiplied everything by 4. Now I need to multiply everything by 2, but this is not a 2, this is 20. Okay, so I do 20 times 9. Let me actually write this. So this is 4 times 9. This is 4 times 30. And then I do, this is 20 times 9 is 180, remember 2 times 9 is 18, but then I also have times 10 here because that's a 2 times 10. And then now this is 20 times 30. Well, 20 times 30 is 2 times 3, but then I also have a 10 times 10, so that's 600. 20 times 30 is 600. And if I add those up, I get 6, 13, 9. Okay, now what's the relationship between these? So these are the two things that I multiplied by 4. And notice that when I did 4 times 9 is 36, and I wrote that here. And I did 4 times 3 is 120, and I wrote that here. If I add these together, that ends up being my 156. And if you think about the operations that you did here, if you look at the operations that you did here with 156, you did 4 times 9 is 36, wrote down the 6, and held the 3 inside your head. And then you did 4 times 3 is 12, and then added that 3. Okay? And this is where you did the 4 times 3 is 12, and you're kind of putting it over in the tens place because that 3 is not a 3, it's a 30. And then you added the 3. Okay? And same thing here. If you dissect what operations you did here, you essentially did 20 times 9. And that's the fact that you moved over and you put the 0 here is acknowledging that this is not a 2, it's a 20. Okay? And then 2 times 9 is 18, which is 18 tens is 180. And then 2 times 3 is 6, but this is 2 tens times 3 tens is 6 hundreds. Okay, so these two pieces went together to get that. All right. I actually encourage people in general to do their stacked multiplication not in this way where you have to hold different pieces in your head, but in this way where you acknowledge every single one of those pieces. Okay, and then you don't have to remember, oh, I multiply this piece and then I add this piece. We get the same answer, and this one actually shows the same picture of what pieces I got here, right? So here was the 20 times 30, here was the 20 times 9, here's the 4 times 30, and here's the 4 times 9. This is backwards from the way that we did it in the stacked version. For the stacked version, we started over here, but you don't actually have to start on the right side or the left side. You can start in any way you want. And in general, like, you can see if I do 39 times 24, I can see I'm just basically adding up, or I'm multiplying each of the pairs of digits. And so this is 30 times 20 is 600. This is 9 times 4 is 36. 9 times 20 is 180. And 3 times 4 is 120. Sorry, 30 times 4 is 120. So I'm just adding these all up. 600, 36, 180, and 120. I can add them up in any order I want. Okay, let's look at this with one more example here. Oh, I want to show one more way of actually drawing this picture, which I call the flexible grid. And the flexible grid is really just, it's looking at this same picture, but again, it's with less detail, okay? So I'm going to say this again. So here's the most detail where you draw out those blocks of 10 when you have blocks of 10, and then you draw the individual ones when you have the individual ones, okay? And then the less detailed is when you just draw along the place value lines. So here's all of my full groups of 10s. There's 3 full groups of 10, and then the individual ones. Here I have 2 full groups of 10 for 20 plus 4, and then the individual ones. So, and again, in this picture, I do actually have, if I was to count all of these individual little squares, I would see in the end that I have 936 individual squares. But blocking this up gives me a way of counting them in blocks that is faster, in big groups, so that I can actually kind of look at a whole group at a time. And so I'm going to take that and I'm just going to make this picture, but not necessarily making it with every single square represented. I can see it as just another less detailed representation of the same calculation. And the way I do this is with what I call a flexible grid. So I'm just going to block out my grid for a minute, and I'm going to draw this in a way that represents that picture but doesn't have all of the individual squares in there for me to count. So 39 times 24, so I'm going to say that is 39 is 30 plus 9. "24 is 20 plus 4. So this is supposed to represent exactly the same picture as what I had up here, except I'm just not making it with every single square inside. It's just made to represent what that picture shows. So when I do this, I know that 20 times 30 is 600. And one of the things that gets me more comfortable with seeing that is by drawing the more detailed grid. But once I'm comfortable with that, I can draw this like what I call a flexible grid. So 20 times 9 is 180, 4 times 30 is 120, and 4 times 9 is 36. So I have 600, 180, 120, and 36. Again, adds up to 936. Okay, let's do one more example. Let's do 22 times 48. Let's look at this, and I'm going to go ahead and I'm going to put the 48 across and the 22 down. Okay, so I now have 22 times 48 depicted here, and I'm going to first block off those groups of 10 for the more detailed version. Okay, and so each one of these squares is 100, and I'm going to actually draw in those individuals. Okay, now when I see this, I'm actually going to also block off those groups of 10 here. All right, now each one of these is a group of 100, okay, and I have 4 by 2 groups of 100. That's this, 40 times 20, okay? So this whole thing here is 4 times 2 hundreds, which is 8 hundreds. Okay, now this piece here is, let's 40 and 8, this is 20 and 2. Now, each one of these strips is a strip of 10. How many strips of 10 do I have? I have 8 times 2 strips of 10, right? There's 8 strips across and 2 strips stacked on top of each other. So there's 8 times 2 10s, and 8 times 2 is 16, so there's 160 here. And here we have more groups of 10, you see. How many groups of 10 do I have? Well, I have 2 by 4. So it's 8 groups of 10. So this is 80. And these individual ones are, how many of them are there? There's 2 times 8 of them. So this is 16. So 22 times 48, oh wait, and let me actually point out that 160, the 800 comes from 20 times 40. The 160 comes from 20 times 4, or sorry, 20 times 8. That's here. That's the 160. And the 80 comes from 2 times 40. 2 times 40 is 80. And the 16 comes from 2 times 8. So my product, 48 times 22, is 800 plus 160 plus 80 plus 16, which is okay. Let's do this again, but with the less detailed version. So in this case, I'm only going to mark off where the place value dividers are. Again, this is 40 plus 8 and 20 plus 2. And now I'm just going to fill in all of those individual products. 20 times 40 is 800. Again, refer back to the more detailed picture of how you see that. 20 times 8 is 160. 2 times 40 is 80. And 2 times 8 is 16. So we have 800 plus 160 plus 80 plus 16 is 1066. Okay, and finally I want to show like the flexible grid version. So the flexible grid version is one where I don't necessarily care to have exactly 1066 individual squares represented in there. I just see this as a representation of this same more detailed picture. So with this one, I'm going to make my rectangle, and I'm going to divide it up along the place value lines. And this is 48 is 40 plus 8. 22 is 20 plus 2. It's kind of representative of the approximate sizes, but not really. I mean, yeah, like the 40 should be twice as long as the 20, but it doesn't matter. This is supposed to be just a representation to make sure that I'm actually doing all of the products right. So 40 times 20 is 800. 20 times 8 is 160. 2 times 40 is 80. And 2 times 8 is 16. So I do 800 plus 160 plus 80 plus 16, again, is 1066. Okay? And again, if I do the stacked method, when I do 48 times 22, again, if I write every single one of those 4 terms there, then it doesn't matter which order I do them in. So I can, a lot of the standard order is to start on the right of the bottom one and go from right to left on the top one, but it doesn't matter. You can start on the left on the top one and go the other direction as long as you're writing all 4 of those terms. Notice that this here, this is 40 times 22, which is these two added up, or multiplied. And this one is 20 times 8, which is these two multiplied. This one is 2 times 40, which is these two multiplied. And this one is 2 times 8, which is, of course, these two multiplied. Okay, so I'm going to do this. I'm going to go kind of the most often taught way, which is to go right to left. So I have 2 times 8 is 16. 2 times 4t, that's not a 4, that's a 4t, is 80. 20 times, so that one, 20 times 8 is 160, and 20 times 40 is 800. I add those all up and I get 1066. Okay, let's do a couple of examples only using the flexible grid to see how that works. Let's actually do this in, let's go big. Let's go 837 times times 25. Okay, now on this one, really the only way I can do this is with the flexible grid because I don't have 837 squares across in or down in my grid paper. So this one we only do with the flexible grid. So I'm going to draw my picture representing 837 times 25. And I'm going to draw my dividing lines along the place value markers. So the 837 is 800 plus 30 plus 7. And I want you to notice that this is not representative. If I call this 800 times and 30 and 7, that is not actually accurate because 800 is much, much bigger than 30. And so these relative lengths are not accurate. But again, this is a representation that's really, at this point, it's going to become a way of keeping track of all of the different products that I have to make. And 25 is 20 plus 5, so I'm going to write that. And now I can see all of my individual products. 800 times 20, well, this is the same as 8 times 2 times, the 20 is 2 times 10, and the 800 is 8 times 100. So I can actually group those things together. So this is 16 here, and this is 1,000. So it's 16,000. 20 times 30 is 600, and 20 times 7 is 140. 5 times 800, this is the same as 5 times 8 times 100, which is 40 times 100, which is the same as 4 times 10 times 100, or 4,000. 5 times 30 is 150, and 7 times 5 is 35. So maybe what I actually do here is maybe I could go, this is adding down, this is 20,000. 16,000 plus 4,000 is 20,000. 600 plus 150 is 750. And 140 plus 35 is 175. So 20,000. And, oh, let's see. I'm going to take 50 from here and make this 800 plus 125 is, that's 20,000 plus 925 is 20,925. Okay, now if I'm going to do this in the stacked version without drawing the picture, it's going to be like this. 837 times 25. I'm going to go 7 times 5 is 35. 30 times, this is 30 times 5. 30 times 5 is 150. 7 times 5, 30 times 5. And we have 800 times 5 is 4,000. Now we're going to do 7 times 20. So 7 times 20 is 140. And then 20 times 30 is 600. And then 20 times 800 is 16,000. And if I add these all up, maybe that feels like a lot to keep track of. Maybe it doesn't. If it feels like a lot to keep track of, I can kind of group things by groups and say this is the same as 185 plus, oh, I really, really want to put these together. This is 20,000 and this is 740. So now when I add those together, 5, 12, carry the 1, 9. Okay. Or you could do that by columns in this original one. So I hope this gave you some ideas about how to model multiplication with pictures, but also how to make sense of why we multiply, why this stacked multiplication works the way it does. I encourage you to try this with a few different examples and also go through the process of drawing the more detailed grid for a few problems that are like, on the order of something less than 50 times something less than 40. Whatever will fit on your paper. And then also drawing the less detailed version and then drawing the flexible grid version, which is kind of representative but doesn't necessarily have the right relative side lengths. Good luck.